Hello and welcome to the series of video lectures on basics of antennas, parameters, types of antennas and their applications. We begin with the basics of antennas. Now what are antennas basically? They are the eyes and ears of wireless communication with which transmission and reception of radio waves becomes possible. Now what are radio waves? To understand that, let us have a look at electromagnetic spectrum, which is the entire distribution of electromagnetic radiation according to frequency or wavelength. Now from the figure, you can see that radio waves are at one end of the spectrum having the longest wavelength or least frequency, and gamma rays are at the opposite end of the spectrum having shortest wavelength or maximum frequency. Now what are different applications of these waves? Now radio waves can freely pass through the Earth's atmosphere and are used in FM and AM radio broadcast, TV, military and satellite communication, mobile phones, wireless computer networks, etc. Microwaves are a subclass of radio waves and are used in microwave ovens, wireless networks, point-to-point communication links, satellite communication, collision avoidance systems, etc. Infrared is used for short-range communication like remote controls, optical fibers, thermal imaging cameras, security systems, etc. Visible light is used for photography, vision, illumination, fiber optic communication, etc. Ultraviolet is used for medical purpose, for killing bacteria, for detecting forged banknotes, for photolithography, etc. X-rays are used in medical fields to detect fractures, for breast cancer detection, observe the internal nature of objects, etc. Gamma rays are ionizing electromagnetic radiations used in sterilizing food and medical equipment, nuclear industry, radiotherapy, etc. So radio frequency range is from 3 kHz to 300 GHz, and microwaves are a subclass of radio waves ranging from 300 MHz to 300 GHz. Millimeter waves are at the higher end of the spectrum ranging from 30 to 300 GHz and can be used for 5G applications. So what's the specialty of radio frequencies? At such high frequencies, wavelength is very small and will be approximately equal to the size of the components used in microwave circuits. So current is not just confined to elements but tends to radiate out as waves. Now coming to the definition of an antenna, it's a metallic device capable of radiating and receiving electromagnetic waves, or is a transducer which converts alternating current to radio frequency fields at transmitter side and vice versa at the receiver side. So from this figure you can see that here you have the source. This is a transmission line. At the end of the transmission line you will be connecting the antenna, and antenna will be radiating the waves out as electromagnetic waves. Now how do antennas radiate? For radiation mechanism, basically you need acceleration or deceleration of charges, and that is satisfied by alternating current, which is a time harmonically varying source. Now for understanding radiation mechanism, you need to understand Maxwell's equations, especially the last two ones, Faraday's law and Ampere's law. This E is electric field, H is magnetic field intensity, B is magnetic flux density, which is equal to mu into H, D is electric flux density, which is equal to epsilon into E. So a spatially varying electric field can create time varying magnetic field, and spatially varying magnetic field can create time varying electric field, and time varying electric and magnetic fields can create electromagnetic waves. See here, you can apply alternating current between the transmission line, and here you will be connecting the antenna which will radiate the waves out as electromagnetic waves. This is a lambda by 2 dipole. When you apply alternating current at the center of the dipole, alternating positive and negative charges will develop across two halves of the dipole. This will create alternating electric field, which will in turn create alternating magnetic field, finally producing electromagnetic waves. Radiation mechanism can be summarized in the form of a flow chart, where you apply time-varying voltage across a two-conductor transmission line, creating electric field between the conductors. Alternating current will produce alternating electric field. These electric lines of force can act on free electrons of the conductor, making them move. Movement of charges will create current. Alternating current will produce magnetic field. Spatially varying electric field creates time-varying magnetic field. Spatially varying magnetic field creates time-varying electric field, and alternating electric and magnetic field will produce electromagnetic waves which are radiated out into space. That explains the radiation mechanism. Thank you.